Yeah. Hi, I'm Bob Craycraft with the University of New Hampshire Center for Freshwater Biology. I'm the lab manager here, and we're in the process of working through an analytical procedure for measuring total phosphorus. This is segment 4 of a series of clips. And we're at the final stages of looking at this analytical process. We have basically prepared total phosphorus samples for analysis. And if you watch the previous clips, we've added some various reagents to the samples, one of which reacts with phosphorus, and the sample turns blue in proportion to the amount of phosphorus in the sample. So effectively, on the left-hand side, we have a sample that's fairly high in phosphorus. On the right-hand side, we have a sample that's fairly low in phosphorus. And to pick up subtle differences in the amount of phosphorus, this instrument to the left, a spectrophotometer, it passes a beam of light through a sample cylinder and measures the absorption of the solution in that cylinder. And effectively, that will help us pick up subtle variations in the amount of phosphorus in these samples. So I had mentioned there's a cylinder we're going to be using, and the cylinder happens to be 10 centimeters long. The longer the length of this cylinder, the more, the higher the, the more sensitive the procedure is. So we're using a fairly long cylinder. Some people use a centimeter cylinder, some use a 5 centimeter. This happens to be 10 centimeters. We've gone through a process before we started filming here and blanked the spectrophotometer out just using a water sample with no phosphorus in it. But now we're going to take the cylinder, and from our flask we're going to pour in some of our sample. The first one will be the 100 microgram per liter, or the high-end phosphorus content sample, rather. So I'm going to pour it in there. I've rinsed it with a little bit of sample. I'm going to pour the sample in here. And the beam of light is going to travel through 2 faces, so I always want to wipe those faces down, particularly if there's any chance that I spilled solution on them. So wipe those faces down quite well. And these are Kim wipes that don't have a lot of debris that comes off of them, kind of like washing off your eyeglasses. They'll clean things up nicely for us. I center that cell in there. I'm going to close the lid, and I'm going to hit the run button. And what we're going to get are a couple of absorption values that spit out. And again, the higher the absorption value, the more phosphorus there is in here. So if you look at these numbers, we're measuring them at 2 wavelengths, 660 nanometers and 880 nanometers. They read 0.416 and 0.636 respectively. For the purposes of this, what I will say is just the higher those numbers, the more phosphorus there is in there. We can clearly see with this sample there is some blue to it, so there's clearly some phosphorus relatively high in that sample. In contrast, we have a second flask that doesn't visually show phosphorus. In essence, it's not blue. Typically, I put my rinse bottle aside, so I'm going to kind of cheat a little bit here. Typically, we rinse this cylinder with purified water between successive samples. I'm going to cheat a little bit and just rinse with sample from our other flask, but understand this is a shortcut that we wouldn't normally take. I'm going to put in our second sample here, our low-end sample, and we'll run this through, and you can get some perspective of the difference in absorption between a very high phosphorus sample and a low phosphorus sample. Again, I'm wiping down the faces because in this case I definitely spilled some solution on the face, and I'm doing a circular wiping, kind of like, again, cleaning your eyeglasses. You want to make sure there's no residual liquid on here, and you don't want any smears on there either. I'm not going to bother with the other face right now because I know I haven't touched that, so that one's okay. I'm going to place this cylinder back in here. I'm going to hit measure. Oops. I'm going to hit measure, and you will see significantly different numbers coming out. So previously it was roughly 0.4 and 0.6 for the 2 absorption values. Now we're down around 0.029 and 0.039. Again, the point being, the lower the number, the less phosphorus in there. And again, the key to this instrument is it picks up subtle differences in the phosphorus that we visually can't detect. So this is a great piece of instrumentation to detect really low levels of phosphorus and really define how much nutrient there is in the sample. The other thing I did do is I made a printout very simply of what we've done in the past. It's just a simple graph showing you the phosphorus concentration on the y-axis over here, And then on the x-axis, the absorption values, and I'm using the 880 nanometer absorption value. Points are as triangles on here, and then there's a relationship line shown there. But the bottom line is the amount of phosphorus is going to be proportional to the absorption value, and we can generate an equation that can show you how much phosphorus is in those samples for unknowns. We always run a series of standards where we know the concentration, and that's what this is. These are the standards. But for any unknowns, such as Highland Lake, we could then plug in an equation, and the points would fall out along this regression line. So that is total phosphorus.
Your recording sheet.
Oh, and what we have, as we're doing this, typically we'd be filling this recording sheet out as we go. So again, we have a series of standards which were used to derive that relationship. We also have some blank samples that don't have any phosphorus in it. And if we were recording everything down here, there's a bunch of blank slots, and that would be your unknowns. That would be the samples from Highland Lake and any other lake or stream we're working with. Occasionally we also run a spike where we add a known amount of phosphorus to make sure we're recovering that phosphorus from the sample. It's a check on our analytical procedure. We run standards periodically throughout to make sure we're getting results that we should be getting. So there are some quality assurance, effectively quality assurance protocols built into this quality control protocols built into this analytical procedure.